If we imagine the whole history of life on Earth taking place in one 24-hour period, the current standard estimates for the origin of life put it at about 3.8 billion years ago, let's say 4 billion. So if we start the clock then, our 24-hour clock, 6 hours, nothing but these simple single-celled organisms appear, the same sort that we saw in the beginning. 12 hours, same thing. 18 hours, same thing. 3/4 of the day has passed, and all we have are these simple single-celled organisms. Then at about the 21st hour, in the space of about 2 minutes, boom, most of the major animal forms appear in the form that they currently have in the present. And many of them persist to the present, and we have them with us today. Less than 2 minutes out of a 24-hour period. That's how sudden the Cambrian explosion was.
In a geological instant, the animal kingdom leaped from small, relatively simple organisms to extraordinary creatures with spinal cords, compound eyes, and articulated limbs. The record of this explosion of life looks nothing like Darwin's slowly branching tree.
Darwin's theory is that there's a tree of life, where you have one organism diverging into many other organisms and big differences appearing at the top. What we really see is from here up. This does not exist in the fossil record. If I were using a botanical illustration, it would be a lawn with separate blades of grass sprouting independently of each other. And those would be the phyla. Now within each phylum, there is subsequent diversification. But even there, I don't see the branches connecting that would make them a tree of life. As scientists, it's not our job to force the evidence into a theory that just doesn't fit it. And so I have absolutely no desire or reason to uphold Darwin's theory at this point.
I think what we're seeing today is a series of scientific discoveries that are opening the eyes of more and more scientists to say, wait a minute, I can no longer believe that pure naturalistic processes can account for the origin and diversity of life. There must be something else here.
The challenges to Darwinian theory have led more than 600 scientists with PhDs from major universities throughout the world to sign a document titled A Scientific Dissent from Darwinism. It reads in part, "We are skeptical of the claims for the ability of random mutation and natural selection to account for the complexity of life."
These are scientists with PhDs from Stanford and Berkeley and University of Chicago and Cambridge, major universities, who've looked hard and fast at the evidence and have walked away saying, I am not convinced. Maybe there's another explanation. Personally, the negative evidence forced me to conclude that Darwinism would require a blind leap of faith that I just had no good reason to make.
Strobel's rejection of Darwinism and materialistic science was also based on the large body of positive evidence for intelligent design. Evidence he first confronted in the science of cosmology, which explores the origin of the universe.
How did the universe begin? What is its source? Few questions have generated as much controversy through the centuries or inspired as many impassioned opinions. I interviewed William Lane Craig, a philosopher who has devoted much of his career to the study of cosmology and the question of origins.
From ancient Greek materialism at the time of Plato and Aristotle up through 19th century idealism, the prevailing view was that the universe is eternal, that the universe never began to exist, that the universe as a whole is, as it were, a static, timeless entity.
This belief in an eternal, unchanging universe, for centuries a pillar of Western cosmology, was unexpectedly challenged in 1915 by Albert Einstein's general theory of relativity. Einstein's equations implied a startling possibility, the cosmos was not static, but instead existed in a continual state of either contraction or expansion.
Einstein did not like the idea that the universe was dynamic at all. In fact, like almost all scientists at the time in the early 20th century, he assumed the universe was static and eternal. What's interesting and ironic is that he thought he had made some kind of mistake in his equations for the general theory of relativity. But a few years after he developed the theory, a Belgian astronomer named Lemaitre developed a model based upon his equations, which again predicted that the universe was in a continual state of expansion.
In 1929, theoretical predictions were confirmed with empirical data. At the Mount Wilson Observatory overlooking Los Angeles, astronomer Edwin Hubble studied light from distant galaxies. Hubble determined that galaxies beyond our Milky Way were moving away from us at a speed proportional to their distance from the Earth. The more distant the galaxy, the faster it is receding. Hubble's landmark discovery led most astronomers and physicists, including Albert Einstein, to a similar conclusion. If the universe is continually expanding, then at earlier points in its history, it must have been smaller and denser.
I think a good way to visualize this is to imagine that the history of the universe has somehow been photographed and made into a movie that we could play on a projector. As the projector runs forward, we watch the universe as it continually expands. But if the projector were to be stopped and were switched into reverse to make the movie run backward, then instead of watching the galaxies move farther and farther apart from each other, we'd see them draw closer and closer together.
As you trace this expansion back in time, the universe grows denser and denser and denser until finally the entire known universe is contracted down to a state of infinite density, which marked the beginning of the universe. At this point, which cosmologists call the singularity, all matter and energy, physical space and time themselves came into being. This literally represents the origin of the universe from nothing. So the startling implication of Hubble's discovery was the temporal finitude of the universe, that the universe had an absolute beginning at some point in the finite past.
During the second half of the 20th century, other discoveries also pointed to a universe with a beginning. These images of the cosmic microwave background radiation document what most scientists now believe is the remnant heat generated during the universe's early history. Background radiation is found throughout the cosmos and indicates its expansion from a sudden, perhaps violent moment in time. This evidence for a finite universe has reaffirmed the conclusion of an ancient philosophical deduction. It is called the Kalam cosmological argument.
The Kalam argument is deceptively simple in its formulation. It consists of basically three steps. Premise one is that whatever begins to exist has a cause. Something cannot come into being uncaused out of absolutely nothing. Premise two is that the universe began to exist. And the remarkable development that has occurred is that for the first time, we now have solid scientific evidence for the truth of that second premise, that the universe began to exist. And from those two premises, it follows logically, therefore, the universe has a cause of its existence. Whatever begins to exist has a cause. The universe began to exist, therefore the universe has a cause of its existence. And that points to a reality beyond the universe, a transcendent reality beyond space and time, and therefore non-physical and immaterial, which created the universe out of nothing and brought it into being.
The implications of a finite universe, coupled with other discoveries of modern cosmology, have led many scientists to unmistakably theological conclusions. There is no ground for supposing that matter and energy existed before and were suddenly galvanized into action. It is simpler to postulate creation ex nihilo, divine will constituting nature from nothingness.
The chain of events leading to man commenced suddenly and sharply, at a definite moment in time, in a flash of energy and light.
We can't understand the universe in any clear way without the supernatural.
Supernatural creation of the universe in a flash of energy and light. You know, it sounds an awful lot like the first chapter of Genesis to me. Today, the vast majority of even the most skeptical astronomers and cosmologists believe that the universe had a beginning. This belief isn't based on some theological doctrine. It's based on scientific evidence. And I think if we follow the evidence wherever it points clearly and powerfully and persuasively in the direction of a creator.
Since the beginning of time, all the matter in the universe has been governed by precisely balanced laws and constants. During an interview with Robin Collins, a philosopher with degrees in mathematics and physics, Strobel learned how these laws offer compelling evidence for a creator and conspire to make the universe habitable for life.
The laws of physics are balanced on a razor's edge for life to occur. For example, if you didn't have something like gravity that pulled matter together, you would never get planets, you wouldn't get stars, you wouldn't get any complex organisms. If you didn't have the strong nuclear force, there would be nothing to hold protons and neutrons together in the nucleus. And so you wouldn't have any atoms, so no chemistry. If you didn't have the electromagnetic force, you would have no bonding between chemicals. You would have no light, and the list goes on. So you need all these sorts of fundamental principles have to be in place in order for life to occur. Wipe out one of those principles, wipe out one of those laws, no life.
Strobel learned that life also hinges on the precise strengths and relative values of many different physical constants. One example of this fine-tuning is the force of gravity.
Imagine a ruler divided up into 1-inch increments and then stretched across the entire universe, a distance of some 14 billion light years. For the purposes of illustration, the ruler represents the possible range for gravity. In other words, the setting for the strength of gravity could have been anywhere along the ruler, but it just happens to be situated in exactly the right place so that life is possible. Now, if you were to change the force of gravity by moving the setting just 1 inch compared to the entire width of the universe, the effect on life would be catastrophic.
No large-scale life forms could exist. Anything that was more than the size of a pea would be completely crushed. So you might be able to get life of a very, very primitive sort, such as bacteria, but you could never get conscious observers.
The strength of gravity is just one of at least 30 separate parameters that must be finely tuned to produce a life-sustaining universe. Another example is the cosmological constant.
The cosmological constant describes the expansion speed of space in the universe. If space expands too quickly, then the universe will spread out so quickly that material objects can't form. So you can't get stars and galaxies and planets and the types of things that we, of course, take for granted in our universe.
Physicists have determined that the cosmological constant is fine-tuned to 1 part in 100 million billion 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 billion. Such precision has been compared to traveling hundreds of miles into space, then throwing a dart at the Earth and hitting a bullseye measuring 1/trillionth of an inch in diameter, an area less than the width of a single atom.
Just consider those two parameters, gravity and the cosmological constant. Their level of fine-tuning is to a precision of 1 part in 100 million